Alright, so welcome to my first video on CXC style multiple choice add maths questions. Alright, so today I'll be doing 10 questions. Let's jump straight into it. Alright, so I want you all to give question 1 a read. It's a very popular type of question in the add maths. Okay, so what's going on in this question? They want you to find the range of this quadratic. So let's just go through the basics here. First of all, well, a quadratic usually has an x squared, an x, and something without an x. If there's no number here, it is automatically 1. If there's no number in front of the x, it is automatically 1. So, I mean, if you're doing add maths for add maths, you'll be familiar with this being A is 1, B is 1, and C is minus 6. So whenever you get a question like this, make sure everybody's on one side and you have 0 on the other side. So if they have some of the items on this side, make sure and throw it across and rearrange it to make it look like this. So when it comes to solving a quadratic, there are a few ways to solve a quadratic. You can use the quadratic formula, you can use factorization, you can even use vertex form. So I'm just going to go with the simplest method, and I'm just going to use the factorization method. Now I'm going to assume that you know how to factorize a quadratic. If you cannot factorize a quadratic, I have a video, a very detailed video on the factorization of quadratics. Okay, so I'll tell you how to access it at the end of the question. So if you were to factorize this quadratic, you would get this: x plus 3 and x minus 2. Now, of course, this whole thing is more than equal to 0. So once you factorize the quadratic, to solve the quadratic, you just put each item equal to 0, each bracket equal to 0. Right? So in this case here is x plus 3 is equal to 0 and x minus 2 equal to 0. Right? So I just put each bracket equal to 0. And you solve for x. For this is going to be super easy to solve for x. When you solve for x here, you will get minus 3. You just throw across positive 3 to get minus 3. And if you solve for x here, you throw across minus 2 to get positive 2. So that means when we solve this quadratic, we get minus 3 and 2. Now, when you have a quadratic, when you draw a quadratic, you either get a kind of U-shaped curve or a kind of rainbow-shaped curve. How do you know what shape you're going to get? Anytime A is a positive value, you always get a U-shaped kind of curve, right? Better known as a minimum curve. If A is a negative value, well, then you get a kind of rainbow-shaped curve, better known as the maximum curve. So in today's question, you will notice A is 1. This is obviously positive 1. So if you were to sketch this quadratic, you would get a U-shaped curve, right? Or better known as a minimum. And remember when we solved the quadratic? Well, this is basically where the curve cuts the x-axis. So it cuts the x-axis at minus 3 and it cuts the x-axis at positive 2. Now we haven't finished the question yet. The question asks us for the range. And so there's a little more space here, this little space here, right? They want to know when the graph is more than 0. Let me put that in plain English. They want to know when this graph, the more than means above the x-axis. So which part of the graph is above the x-axis? Won't it be this part here? I'm just making a dash. And won't it be this part here? So the dash part is above the x-axis. So how do you write that answer? Well, whenever x is more than 2, well, when it's more than or equal to 2, as we go this way, it's above the x-axis. And similarly, when it's less than minus 3, less than or equal to minus 3, it's above the x-axis, right? You notice the question came with a more than or equal sign. It had a little extra line underneath. So that means my answers must also have the extra line underneath. Right, so that's the answer for this question. Now I just want to show you, a lot of students get confused because you notice it's two separate answers. Let me show you something. You notice that the two dashed lines are separated from each other. This dashed line does not touch that dashed line. Once the two regions in consideration do not touch each other, you get two separate answers. So let me show you the evil twin to this question. Let's say if the question was changed to this instead. Instead of more than or equal to, it was less than or equal to. So we would do the question the same way. Well, let me change it up a little bit. Let us call it less than. So let's say you got this question in the exam now. Well, now they're asking which part of the curve is below the x-axis. Well, below the x-axis would be, I'm going to put it in blue. You notice, unlike the other question, how this dashed line was separated from this dashed line. You notice this blue line is one line. Okay, no part of this blue line is separated from the other part of the blue line. It's just one line. Whenever your answer is one line, your answer has to be written in one line. So it will be written like this: minus 3 is less than x, and x is less than 2. This means this region here. And because the region is connected and not separate, my answer is one straight connected answer. There isn't two separate answers. Okay? So I hope that you understood this question, and I hope you understand the two different ways it can come. And you notice the question, my made up question, did not have the extra line underneath here, which means my answer will not have the extra line also. Right? So those are little tricks to look out for in the multiple choice. Alright guys, let's get started with question 2. Alright, so let's get started with question 2. Alright, so before we go into question 2, let me just revise a small piece of theory. Let's say, look at the green part here. This is my own made up question here now. Let's say we have g minus 1. Now you all know that g minus 1 really means g inverse. So let's say if the examiner says g inverse x is equal to 4x plus 2. Then they ask you to find g inverse 3x. How would you do a question like this? Well, simple. Whatever you have in the brackets, you kind of work backwards and throw it into the function they are referring to. So what they're asking to do is take 3x, go to g inverse, and wherever you see an x, throw away x and replace it with 3x. So remember, for this to work, we need to know g inverse because we are putting it into g inverse, and it so happens we have g inverse. So let's write back g inverse here. 4x plus 2. Remember, they want us to go here. Wherever we see an x, erase it or throw it away and replace it with whatever you have in the brackets. So we have 3x. But whenever you're replacing something in maths, please put it in brackets. So 4 by 3x is 12x, and we have a plus 2. So this is the answer for this particular question. But it was only easy because the examiner gave you g inverse in the first place. So let's try the official question here now. Alright, so they told us fx, the function x, is 3x minus 4. Now there are two ways to write functions, like this, or they might put 2 dots x and an arrow. This and this is the same exact thing, right? So I know sometimes they write it like this in past papers, and sometimes they write it like that. So I didn't want you to get confused. So I put both on the paper just in case. Here's the thing now. They told you that f gx is equal to x, and they want you to find gx. You can think of this as a transposing question. Let's say I had x plus 3 equal to 5, and I wanted to find x. Well, you know in maths, you will keep x on one side and throw everybody else on the other side. But when you throw something across, it becomes the opposite. So positive 3 will become negative 3. So positive becomes negative. Multiply if you throw it across becomes divide. Squared when you throw it across becomes square root. The moral of the story, it becomes the opposite when you throw it across. So if we want to solve for gx, that means we need to keep gx on one side and then throw across f on the other side. But when you throw across something, it becomes the opposite. So when you throw across f, you are going to get f inverse, and don't forget what's waiting here is x. So to find gx, we just have to work this out. As simple as that. So all we need to do is find f inverse and then throw x into it. So that's the plan. Let's find f inverse. To find f inverse, let's do it for space here. F inverse, you change fx to y, and then you put 3x minus 4. The next step is you switch x and y. Wherever you see a y, change it to x, and wherever you see a x, change it to y. Let's solve for y. Well, you throw across minus 4 to get positive 4, and this is equal to 3y. Now, you're trying to solve for y. There's a multiply here. Throw across a multiply, and you will get divide. Once you make back y the subject, well, we have just found f inverse. So this is f inverse. F inverse is equal to x plus 4 divided by 3. And don't forget you have an x here now. All they want you to do is put x inside of f inverse, which is kind of useless, and you're going to see why. This is f inverse here. This is the function. They want you to erase x and replace it with whatever we have here, which is x. So it doesn't really change anything. So gx is equal to this worked out. So gx, this is the answer for it. gx. Alright, so I really hope that you understood question 2. On to question 3. Let's have a look at it here. Oh, this is going to be a super easy question. Question 3 is checking to see if something is actually a function. Well, what we can do is use the vertical line test. The vertical line test is you draw a few vertical lines through the graph, not horizontal and vertical. And the vertical lines can only cut at one point on the graph at a time. If it cuts at 2 or more, it is not a function. Let me show you. Let me explain why this is not a function. If I were to draw a vertical line, you will notice it cuts the graph at 1, 2 places. Even if I draw a next line here, it still cuts at what? 2 places. Any vertical line I draw, once it cuts at more than 1 place, it's only allowed to cut at exactly 1. It is not a function. So he is not a function. Is he a function? Yes. If I draw a vertical line here, it only cuts here. If I draw a vertical line here, it only cuts the orange graph at 1 point. If I draw another vertical line here, it only cuts the vertical line at 1 point. So this is a function. Right. Next now. This is a strange one. If I draw a vertical line over the orange line, the blue line cuts the orange line at an infinite amount of points. It overlaps the line. So it clearly cuts the line at an infinite amount of points, which is more than 1. So this is not a function. This is the only one which is actually a function. Alright? So hope you understand question 3, and on to question 4, which is a logs question. Alright, so question 4, like I said, is a logs question. So above here are the formulas that I'm going to use to do this logs question, right? So I'm going to be referencing them as I do question 4. So question 4 says log ax, wherever I see that, it's equal to 5. So that means wherever I see this, I can throw it away and replace it with 5. And similarly, log ay, so I said y here, I meant x, right? But log ay, wherever you see this, it's equal to 4. So wherever I see log ay, y, I can throw it away and replace it with 4. So the question asks us to find log a x squared divided by y. Now this squared only belongs to the x. Let's get that clear first. So you notice you have a divide situation here. Whenever it's a divide, you can split it up with a minus sign. So this is equal to, let me get a different color marker here. You will get log a x squared minus log a y. Right? So divide means you can split it up with a minus sign in between. Great. You will notice that there is a squared here. According to rule number 3, whenever you have a power, you can throw it in front. You notice how this lands in front now? So this squared can actually go over here now. And of course, there's a secret multiplier in between there. So it seems that we only use 3 and 1. Well, I guess I wasted space right in 2. We didn't need it after all. So let's finish out this question. Here we have a 2 multiply. Wherever you see log ax, you can replace it with 5. So this whole thing is replaced with 5 minus log a y, and log a y is equal to 4. So we can replace him with 4. We're almost done, believe it or not. 2 by 5 is 10 minus 4. The answer is 6. Super easy. Alright, number 5. Alright, so question 5 is an AP question, an arithmetic progression question. So they want you to find the sum of the numbers of the odd numbers between 10 and 60. Now, there are 2 ways to do this. Short way or a very long way. I'm going to try to discuss the short way but reference it to the long way. So if you want to find the sum of an arithmetic, an AP, this is one of the formulas where you just need to know A, which is the first term, and L is the last term, and N is the number of terms. Alright, so they want you to find the sum between 10 and 60. Obviously, if you start at 10, 10 is an even number, so the next odd number would just be 11. So if we keep counting up to 60, 60 is an even number. The odd number just before 60 would obviously be 59. So at least we know the first term and the last term. So the first term is 11 and the last term is 59. Alright. But it's the amount of terms. Remember, the long way of doing this is saying 11, the next odd number is 13, then 15, then 17, and you count all the way up to 59 with all the odd numbers, and then you add up, and then you add up how much numbers you have. 1, 2, 3, 4, 5, and whatever you get, you replace n with that. You could do it like that, but you're going to waste a lot of time in the exam. So here's a different way of finding n. Let's say you are asked to find the amount of odd numbers between 10 and 14. This is pretty easy because it will be 11 and then 13. There are only 2 odd numbers between 10 and 14. So what's another way of getting 2 numbers? Well, you could just simply minus the last number and the first number and just divide it by 2. 14 minus 10 is 4. 4 divided by 2 is 2. 1, 2. But let's see if it works for a bigger one. Let's say we wanted to find the amount of odd numbers between 10 and 20. Well, that would be 11, 13, 15, 17, and 19. That's 1, 2, 3, 4, 5. So let's see if this formula still works. If we minus the last number and the first even number and then divide it by 2, we get 20 minus 10, which is 10. 10 divided by 2 is 5. 1, 2, 3, 4, 5. So we see that the pattern, or our technique works here. So to find the amount of odd numbers between 10 and 60, you minus 10 and 60 and divide it by 2. 60 minus 10 is 50. 50 divided by 2 is 25. So that means we just have to replace n with 25. And we just work this out in our calculator. right? 11 plus 59 is 70, multiplied by 25 divided by 2. And we'll get 875. And that's our final answer for this particular question. And this is very useful because I could see an examiner, to me, you could have still counted out and get this question in probably under 2 minutes. But suppose it was 10 and 600, or between this and that. Were you really going to count that out in the exam? You have wasted a lot of time in the exam, right? And you notice when I was using a smaller version to this question, I used a particular format. The first number was even and the last number was even. So I made sure my first number and last number was also even. And I looked for a pattern. I would advise you to do the same thing in the exam, right? I'm just double checking the answer here. 25 divided by 2 multiplied by 11 plus 59. Yep, I'm correct. 875. Alright guys, let's have a peek at number 6. Number 6, integration. Alright, so question 6, I went ahead and put most of the work in on the board. So let me just discuss what's going on here. They want you to find the volume if you take this graph and rotate it by 360 degrees about the x-axis. So this here is the formula to find volume. Pi integral y squared dx. Now notice there's a squared here. The examiner gave you the formula for the graph and this is equal to y. So y is equal to this. So what I did, I threw away y and replaced it with 2x minus x squared on 2. And don't forget the formula says that we need to square it. So I think we need to simplify this first, and then once we expand the brackets and simplify it, then we will attempt to integrate it. So remember what squared means. Squared does not mean you just simply square everybody in the brackets. Squared means you're going to take each bracket and multiply it by itself. So how do you expand this? Well, you just simply block him and multiply both of them by 2x, and then block him and multiply both of them by minus x squared on 2, which I did below here. Notice I took the 2x and I multiplied it by this bracket. Then I took this bracket and multiplied it by minus x squared on 2. Now you have to take your time and multiply this out, but I kind of went ahead over here. Ready? Hope you can see. Right? When you expand this bracket and this bracket, the green and the orange, you are going to get the top row here. This can be further simplified to this, because minus x cubed minus another x cubed is minus 2x cubed, right? So I went ahead and did the calculations. So what I'm going to do now, I am going to attempt to integrate this, because once we expand the brackets and simplify it, but once we simplify this, we will get this. All right, so let me erase the board and let me integrate this. All right, so let's integrate this. Now I just forgot out something very slight. Remember, we are trying to find the volume between 0 and 2, so I was supposed to write the limit 0 and 2, right? So I wrote it in here now. Let's integrate this. Remember, you add 1 to the power and divide by the new power. So for this, we will get 4, add 1 to the power, you will get 3, and divide by the new power. For this one here, add 1 to the power, you will get 4, divide by the new power. This one here, add 1 to the power, we will get 5. Remember, there's a 4 here, so and we have to divide by the new power, so the 5 meets the 4. So let's just quickly simplify this. This is just nothing much here. 4 on 3x cubed. 2 will go into this to give us minus x to the power 4 divided by 2. Remember, 1 multiplied by anything is itself, so I'm not going to bother to put the 1. Plus x to the power 5, and 4 by 5 is 20. And once we integrate it, we put the square brackets and we put 2 and 0. So all we have to do now is replace all the x's here with 2, write down the answer, put a minus sign, then replace all the x's here with 0 and write it here and minus both answers. Now the 0 is going to be super easy. If we replace all the x's here with 0, we're obviously going to get 0. So I guess it's just this one here. So we just have to replace all the x's here with 2. So make sure and put it in brackets so you don't make any mistakes. And this one here with 2. Alright? So this is going to be up to you to work this out, but I'm going to pause the video, work it out, and come back and tell you what answer I got for this, and I'm going to put it right here. So 1 second, guys. Alright, so when I worked this out on my calculator, I got 4.27. I had to round it off, but that is what I got. Right, so this minus 0 is 4.27, but we have one more thing to do. Remember, there was according to the formula, there was a pi waiting outside. Well, when we get this answer, we cannot forget to put the pi next to it. Obviously, there's a secret multiply here. But this here is the volume, so it will be in units cubed. Alright? So that was number 6, which was an integration, and number 7 is another type of integration question involving tricks. So 1 second, guys. Alright guys, question 7, another integration question. Alright, so here are the formulas that you're going to need to integrate sine and cosine. Right, I'm sure you're very familiar with them. When you integrate sine, ax, like if there's a number here, whatever is touching the x goes underneath the a. Sine changes to cosine, whatever you have here remains the same, and when you integrate sine you get minus the cosine of that. And it's almost the same thing if you integrate cosine, right? The same exact concept, except when you integrate cosine there's no minus sign here. Alright, so you need to write it down, right? If you didn't know it, we're going to integrate this above here. Alright, it looks like a pretty simple question. Don't foresee any tricks in it. So if you integrate sine, remember you get minus cosine. So and whatever is touching x goes underneath. So when you integrate this, you'll get minus. You have the 4. Sine changes to cosine. It remains as 2x, but whatever is touching x, a copy of it goes underneath here. Right? We'll simplify that just now. And this one here, it's super easy. When you integrate cosine, you get sine, right? And there's a 2 here, right? And don't forget to put the plus on the c. Alright, so I guess we can simplify this a little bit. Right, so let's double checking something here. Right, everything is correct. So we can simplify this here. 4 divided by 2 is 2. Right, and this is the answer here. But, oh, I know the trick they're going to put on you. When you look in the A, B, C, and D, you're not going to see this anywhere. Right? So what they might have done, they might have factorized out the minus 2 and left it as cos 2x plus sine x. Right? Remember, you pull out the minus 2 from both of them, and then you'll have the plus c there. So this is the answer that I don't foresee this as being one of the answers. This is too easy. They made it a little bit harder. So they factorized out the minus 2. Alright, so pretty simple stuff. Let's move on to number 8. Oh God, another differentiation and integration question. Alright. Okay, give me a few seconds just to write this back on the board. Alright, number 8. Okay, so before we go to number 8, there's a small piece of theory you need to know. If you want to integrate 4x, right? You notice 4 is a constant, but x is a variable. You may not know this, but I'm letting you know now. When you're integrating, if you have a constant, you can put the constant outside. You can think of it as factorization, and just pretend the integration sign is a brackets, and you're going to pull the 4 outside. So you can pull the 4 outside, and that, since the 4 is outside, like outside of the integration, all you have to do now is integrate x, and whatever you get, you can multiply it by the 4 at the end of the question. Now this pulling out of something only works if it is a constant. You cannot pull out the x, only the constant. So let's apply this to this. Let's pull this into view here. So they tell you that if you differentiate this, you will get this answer. Now what you have to kind of remember is integration and differentiation are like opposites. So that means if you differentiate this, if you get this, that means if I integrate this, I should get back the original expression. So you can think of differentiation as a forward direction, and if you want to reverse the process, you integrate. Okay? So it's like forward and backwards. So they want you to find this guy here. So let's put this into play here. We have 5, and then we have 1 plus x and the square. And well, the dx just means we are integrating x, right? You'll notice that 5 is a constant. So if we want, we can pull him outside and we'll be left with a 1 on top there, right? So kind of like we factorize out 5. So it's going to be kind of hard to integrate this expression, but the examiner gave us a hint. Sorry, put the 0 and the 4 here. Remember, if we block the 5 now, and we pay attention to this, if we integrate this expression, we're supposed to get back the original expression. Remember I told you about the forward and the backwards? So that means if we integrate this, we will get x divided by 1 plus x. So, and don't forget the 0 and the 4. So that means if we integrate this expression here, let me erase it quickly. Use my hands. Right? If we integrate that expression, we will get x over 1 plus x. And don't forget to put the square brackets because we just finished integrating. And the limits are 0 and 4. Right, so you see the relationship between this and this. It doesn't look the same until we factorize out the 5. Then it looks the same here. Alright, so did I make any mistakes? No, x plus 1. Right, so it's just for us to work this out. We just have to replace all the x's inside here with 4. Then replace all the x's inside here with 0. Minus both of them. And then multiply by 5. So let's handle the brackets first. So that means we have x on 1 plus x minus x on 1 plus x. Remember in the first instance we are replacing all the x's with 4. Right, it's not the best choice marker. Alright, that's a little better. And now we're replacing all the x's inside here with 0. And we minus both answers. Well, this is going to work down to 0. 0 divided by anything is 0. And here we have 4 divided by 5. So when we work this out, we're going to get 4 divided by 5. But whatever we get, remember there's a multiply by 5 weight in here. So the 5 and the 5 will cancel out. So our final answer is 4. Right? So you should see that answer between A, B, C, and D. Alright? So for number 9, they want you to solve for K here. So they want you to integrate this expression between 0 and k, and whatever we get, we're going to put it to equal to 40 over 3. So I already integrated it here, but I'll still go through the steps. Remember, when you have x is really x to the power 1. So you have to add 1 to the power, so we get 2, and then we divide by the new power, which is 2. When we integrate a constant, we just put x. And here we have the limits, 0 and k. So what we're going to do, replace both x's with k. So you'll get k squared on 2 minus 4k. And then we have to put a minus sign and then replace all the x's with 0. Now if we replace all the x's with 0, this whole thing is going to boil down to 0. So I'm not even going to bother to put it. We're supposed to, the examiner said that when we integrate this, we're supposed to put it equal to 40 over 3. And we have to solve for k. Now this is clearly a quadratic. But let's get rid of the denominators, the 3 and the 2 first. So let's multiply both sides by the LCM, which is 6. So let's visit every one and multiply every one by 6. 2 into 6 is 3. 3 by k squared is 3k squared. 4 by 6 is 24. And don't forget to put back the k. And well, the 3 will go into this 2 times, and 2 by 40 is 80. So to solve this quadratic, we just throw everybody on the same side. 3k squared minus 24k minus 80 is equal to 0. This is A, this is B, and this is C. And you can choose whatever method you want to solve this quadratic. Right now, I'm just going to use a shortcut on my calculator. A is 3, B is 24 minus, and C is 80 minus. So when we solve this, we're going to get K as 10.53, and the other answer is minus 2.53. Just double checking my answer. A is 3, B is negative 24, and C is negative 80. Yep, that is correct. Right, so this is it's like a super popular question in the exam, right? If you come down to the end of the exam, you'll be seeing questions like this in like in number 40 or 35, around there. You'll be seeing those types of questions. Now, sometimes when they will give you an expression here, now when we integrated this expression, right, and we substitute in the k and the 0, we happen to get a quadratic, and quadratics are easy. But sometimes the expression here, when you integrate it and do the substitution, you do not get a quadratic. Instead, you get a polynomial. That's like, you get like k to the power 3 and whatnot. So those questions will be slightly harder, but I'm guessing by now you all know how to solve a polynomial. That's the one where you have to guess the first value, and whatever you guess, you divide the whole thing by the first factor and you get a quadratic, and then you have to go on to solve the quadratic. Right, so hopefully in my next video I will do a question where these types of questions boil down to a polynomial. So last question, question 10. Alright, so the next question is a differential question. So the examiner gave us a curve here and told us that the equation of this curve is fx is equal to sine 2x. Now, I just drew a curve here. Right now, in reality, sine 2x will not look like this, but it won't affect the question. What they want us to do is find the gradient at this point. Now, when you hear the word gradient, the first thing that should come to mind, especially if you do the maths, is differentiation. Because when you're differentiating something, you're already finding the gradient or an expression for the gradient. So all they want us to do in this question is to differentiate this and then replace x with pi on 6. That's all they want us to do. So if we differentiate sine 2x, we are going to get 2, well, I'm going to write it underneath here. When you differentiate this, you will get 2 cosine 2x. Remember, you're differentiating, you throw the power, so you throw whatever touching x in front. This is differentiation, and don't mix it up with your integration formulas. And when you differentiate sine, you get cosine. Great. Now they want you to replace the x with pi on 6. Now, they put the x-axis in radians. Remember, pi on 6 is ready 30 degrees. So that means pi on 3 is ready 60 degrees. So cos 2 multiplied by cosine 2, and we are replacing this with pi on 6. 2 into 6 here is 3. So, sorry for writing here. 2 multiplied by cosine pi on 3. Now, some of you all may not know how to change a calculator to radians mode, or may not want to change it to radians mode, but cosine pi on 3, number pi on 3 is really 60 degrees. So if you were to work this out on the calculator, 2 multiplied by cosine 60, the answer would be 1. The gradient at this point is 1, right? And this was actually question 10. I made a mistake. Not a mistake, I just forgot to update the question there. Alright guys, so that's 10 questions, 10 additional mathematics multiple choice questions. In my next video, I will be doing another 10 questions. Now guys, it will make my life like much easier if you all were to like message me and tell me, hey, which questions exactly are giving you all problems, right? it will make it easier for me to select now, because usually when I'm trying to do questions, I have to try to imagine that I am the student and I'm trying to figure out, hey, is this question worth discussing, or should I choose another question, right? So first things first, if you want access to my free online classrooms, just WhatsApp me on this number and say holy spaghetti rainbows in a message. And of course, this is the same number to message me on to tell me which maths questions, multiple choice questions are giving you problems, right? And throughout the week I will gather the questions, and in my next video I'll try to choose the hardest of the ones everyone sent me. So I kind of like it will suit what you need, right? Alright guys, so thanks for watching. Of course, don't forget to subscribe and share, and well, thanks for watching.